Very good morning. Welcome you all to the NPTEL course on Economic Operation and Control of Power Systems. Today we'll be focusing on the concept power pools. Now different nations do adopt different mechanism to cater energy to their consumers. Because of competitiveness, because of bilateral and multilateral transactions, different models are being adopted for smooth functioning of those transactions. So power pool is one of the concepts being practiced commonly in North America, is one of the example where we can understand how transactions are being carried out successfully and being implemented for smooth functioning of utilities. Now when you talk about power pools, the power pool mainly, is a central dispatch unit which maximize many economic benefits. Now one of the main important achievement through power pool could be minimizing the operating cost, indirectly maximizing the operation or operating efficiency. Now what exactly a consumer expects from you or from a utility is to have electricity with cheaper cost. So we have to explore the competitiveness, and through transparency we can make sure that the minimum cost to the energy can be achieved. Now we can also perform a system-wide unit commitment, because assuming the transactions and other units status, a new unit commitment algorithm can be carried out. Now PowerPool can also minimize the reserves being carried through the systems. Sometimes we used to have excess reserve towards the reliability, but that may certainly cost you too much for your energy price. So that is also another area that need to be optimized. It can also coordinate maintenance scheduling to minimize cost and maximize reliability by sharing reserves during maintenance period. It can also maximize the benefits of emergency procedures. Being said that, there are n number of issues that need to be improved, and it is little bit of a demerit, or I can say disadvantage, to pool operation, and we have to be careful before implementing pool model to a new utilities. The complexity of the pool agreement and the continuing cost of supporting the inter-utility structure required to manage and administer the pool. The operating and investment cost associated with the central dispatch office and the needed communication and computational facilities, because that is another layer we are introducing over existing layer, so certainly it is a cost issue. The relinquishing of the right to engage in independent transactions outside of the pool by the individual companies to the pool office, and the requirement that any outside transaction be priced on a split saving basis based on pool members' cost. The additional complexity that may result in dealing with regulatory agencies if the pool operates in more than one region or state. The feeling on the part of the management of some utilities that the pool structure is displacing some of an individual system management responsibilities and restricting some of the freedom of independent actions possible to serve the needs of its own customer strategy. Now, there are a few questions that I am raising here. Who will pay what to whom for all the economic transactions and special reimbursement built into the pool agreement? Because we need to have clarity, the benefit, whether it is an independent system operator or the pool mechanism can gain profit out of it. So we have to be very careful before adopting any pool mechanism. No pool member should have higher generation production expenses that it could achieve by dispatching its own generation to meet its own load. Now power is sold to and purchased from the pool, and participants' accounts are updated currently. After the fact computation, each participant does an own load dispatch to determine how much it would have cost to just serve its load. Some participant own load cost and subtract actual pool operating cost, and that is their saving. For example, if I do operate my own generation to meet my own load, I would have spent rupees X, but going through a pool mechanism, if it is 0.9x, then I can say 10% of saving is certainly possible. Now, the term energy broker is a very important concept because the broker is someone who really a kind of intermediate person between the consumers and the pool manager, doing many bilateral transactions deals between companies, and marketplace is quite haphazard. Central broker accept quotations to sell and quotation to purchase creates an orderly marketplace where supply, demand, and prices are known simultaneously. Now, to understand one broker mechanism, let us focus on one utility, that is Florida Energy Group Broker, and what they do and how do they make profit, as well as make their consumers and suppliers happy. Now, if you go for hourly, each member sends incremental cost and megawatt willing to sell, or decremental cost and megawatt willing to buy. That means we expect each entity to give these two offers, sell and buying cost. Once all the data related to selling and buying is available with the broker matches lowest cost seller to the highest cost buyer. So what the broker will do? Try to get the energy which are available to him cheaply and engage those consumers, those are ready to buy with a higher cost until all megawatts are sold or purchased. So as a seller, I will be, tempted to offer a lower price so that my energy is being sold. Similarly, as a consumer, I will offer a higher price to make sure that I have not been left out without electricity. Now, if you do this process split, so there are a lot of benefits. So if you see the amount received is X and the amount spent is Y, the end of the day, there is a saving called X minus Y, and that need to be distributed across the utility entities with a different mechanism. So the split savings model works as follows. What they do, Fs, which is incremental cost of selling utility, FB is the decremental cost of the buying utility, and FC is the cost rate of the transactions, and that will be Fs plus half of FB minus Fs, that is half of Fs minus FB is the cost rate for each transaction. Now, let us look at a very simple example. 4 power systems have sent their buy-sell offers to the broker. They are A, B, C, D. A and B are selling energy and C and D are buying energy. In the table below, these are tabulated and the maximum pool saving possible is calculated using a uniform pricing mechanism. Now, if A and B are two different utilities interested to sell their energy with an incremental cost offer of 25 and 30 respectively, and with a magnitude of actually 100 megawatt hour each, then probably the seller's total increase in cost will be 25 into 100, that is 2,500 and 3,000 respectively. So indirectly, the broker has to pay 5,500 rupees to buy energy from both utilities, A and B. Now after that, he has consumer C and D who is ready to buy this 200 megawatt in a fashion. One is ready to buy 50, that is C utility, and the second one is 150, such as D utility. Now the question is, consumer C and D are ready to buy energy with a cost which is 35 and 45. So the cost will be 1,750 and 6,750. So the pool, the broker or the pool entity will have the benefit, which is 1,750 plus 6,750 being received from the consumer C and D and being paid to A and B, that is 2,500 plus 3,000, and net saving is going to be 3,000 rupees or dollar. Now, this is a very, very simple example. Anyone can understand this mathematics. But the important factor is, it is important that this 3,000 rupees profit need to be minimized. Because because if you like to encourage a competitive market, then this profit has to be as minimum as possible. So probably assume that this profit is going to be zero. What does it mean? That the broker has played an important role to connect two very interesting consumers as well as seller directly. Am I right? So the utility has to take care that this profit that is being created must be reasonable and should not be beyond a particular value. So how do we guarantee? That's a question we need to answer. Now let's say the broker set up transactions such as A is selling 100 megawatt to D and B sells 50 to D and B sells 50 to D. That means the D consumer is getting actually 200 megawatt hour from both A and B in three different ways. Now, when you calculate the saving, because the purchase is 45, selling is 25. Second case, purchase is 45, selling is 30. The third one is purchase is 35, selling is 30. So then each level you save some money. That is 2,750, 200. So indirectly 3,000. That's what we calculated earlier. Will become my saving. Now the rates and the total payments are easily computed under the uniform pricing arrangement at the price of the last match, the highest value. If you calculate the saving computation become, if it is slightly higher, let's say 37.5, then probably you can increase the profit from 3,000 to 7,500. And if that profit goes as high as possible, the time may come that the system may collapse if the profit become higher and higher over a period of time. So it has to be reasonable so that the consumers must be happy to buy, as well as the sellers must be happy to sell without worrying about extremely minimum price to sell and extremely higher price to purchase. So thank you very much, and we'll move to one more important section, so-called transmission effect and issues, during our next class. So thank you very much for your attention. Thank you.